So SDP finally worked again. So I'm just gonna really quickly go over the AMS quiz for tomorrow. It's really easy. So which of the following is true about the crystal lattice of a molecular substance? Molecular substance, it's made up of ions? No. It's made up of molecules? Of course, it's a molecular substance. Atoms? Nope. Transition metals? Nope. Alkaline earth? Nope. If it's a molecular substance, it's obviously made out of molecules. So this is really obvious. Now, which of the following is true about the lattice structure? It's a 3D pattern of points. Yes, it is, because it's a lattice. Let's say it's an ionic lattice. Positive, negative. Actually, positive will be full circle, negative will be like empty. Positive, negative, positive, negative, negative, positive, negative, positive. Like, you get the picture? It's gonna be, then they're gonna go behind each other, and they're gonna make like this cube. It's gonna be a lattice. It's gonna be 3D. It designates the positions of the molecules in a solid crystalline. Yes. Atoms in an atomic. Yes. Ions in an ionic. Yes. If it says molecules in solid, then it's correct. If it says atoms in atomic, of course. Ions in ionic. Yes. Components in amorphous solids? No. What's that have anything to do? Okay, so HCl, we know that an acid with a carbonate forms bubbles or effervescence of gas. And the net ionic products are going to be CO2 and H2O, of course. Okay, so metals are obviously good conductors, definitely not brittle. They have high melting points. They're definitely not bad conductors. They're malleable and ductile, and they definitely don't have a low melting point. Substances such as F2, P4, and S8 are molecular because they're molecules. So they have weak attractions called VDW or van der Waals between their molecules, and van der Waal attraction means they have a low boiling point and a low heat of fusion. Elements that are found in network structures. We only have two examples where it's just carbon and silicon. Let's say in the exam they didn't give it to us, then most likely it's gonna be a group 4 element, but most likely in the exam, these are your only two options that you're gonna get. A giant structure that has particularly pattern of covalently bonded atoms is called a network solid. This, you actually kind of have to know it. It's really easy. Now, which ones are in metallic bonding? You have to choose the two metals out of the options. Now, they're gonna ask us, metals are something agents because they have a tendency to something electrons. So we have to remember oil and rig from reduction and oxidation. Now, we know metals, obviously they lose electron to become cations. They become positively charged. So this one, you write it down first. Now, how to know what type of agent it is? If it's losing electrons, we need to remember oil. Oxidation is loss. Reduction is gain. Oxidation is loss because we're losing electrons. Now, if it's losing electrons, it's oxidizing. It's oxidizing. And we know that the thing that oxidizes is the reducing agent. It helps in reducing the other thing. So anytime it's losing electrons, it's a reducing agent, but it is being oxidized. Now, metals are malleable and lustrous. You have to memorize this. They have high electric conductivity and high thermal conductivity. Also, memorize this. These are some properties of metals. Conducting. Okay, listen. When they ask thermal conductors, it only can be gold and brass. It can only be metals. Graphite is not a thermal conductor. It doesn't conduct heat. But it's an electric conductor, which I think is the next question. Yep. Electric conductors. So graphite is obviously an electric conductor because it passes electrons. Gold is one too because it's a metal, and brass is also a metal. Now, solids that do not conduct electricity and have high melting points are called ionic. How do we know this? By the do not conduct. Now, network solids are diamonds and graphites. These are the only two examples we have to know with silicon, of course, which can be written as quartz. Okay, for this one, H is in group 1 and F is in group 7. So H has 1 electron to give and X has 1 electron to give. Same thing here, S except is in group 6, so it has 2. So it's going to make 2 bonds with the H on each side. MgF is ionic, MgF2. So you're going to have 1 Mg and 2 Fs. Each F is going to have 1 cross from the Mg, and the Mg is going to be surrounded by a empty shell. Here, N needs 3 electrons, so it's going to get 1 from each hydrogen. Here, Na plus and I2 minus. If it's I2 minus, then you need 2 Na pluses to cancel it out. So if the answer was and like this, then this would be correct, but it's not, so it's not. Now, sodium iodide is a salt that can be mixed with sodium chloride to produce iodized table salt. So sodium iodide is lattice structure, of course, since it's ionic. It's composed of oppositely charged ions, again, since it's ionic, held by ionic bond. We can figure out why, because it's ionic. Type of forces that hold silicon and diamond. Silica and diamond are strong. Diamond is a network solid. It's a network solid. So network solids are always held by covalent bonds only. But in diamond and silica, the electrons are localized. In graphite, the electrons are delocalized, since it can conduct electricity, of course. Now, in a metallic bonding, it's an array of cations, specifically cations, positive charges surrounded by a sea of delocalized valence electrons. This is also a memorizing type question. Okay, so now you need to match which property is for which reason. Metallic luster, it's because the electrons, they'll absorb the light and re-emit it. That's why it looks shiny. Conductivity, because the electrons are free to move. When you see the word move, it means electric conductivity. Thermal conductivity, it's because they're under high temperatures, they can acquire kinetic energy. And then when they move rapidly through the metal, they give their energy to the cooler parts. This is pretty obvious. Malleability, because non-directional bonds. Whenever you see the word non-directional bonds, it's because it's malleable. This question, of course, we already know it, but let's do it really quick. NO2. Now, O is always -2. Unless it's with F, then it becomes +2. Wait, is that? Yeah, it is. So -2 times 2, -4, x minus 4 equals 0, so x equals 4. So n is 4, and this is -2. Now, H, we know it's 1. Cl is our x, so 1 plus x. And O is -2 times 4, -8, equals 0. So 1 minus 8 is -7. So x minus 7 equals 0. X equals 7, and that's for chlorine. So 1 for H, 7 for Cl, and -2 for O2, for O. MnO4, so it's x minus 8 equals -1, because it's a minus. So x equals 7, and -2, of course. Now, this is cathodes and anodes, what you find at them. Concentrated, KBr. Now we know when you have a solution, it's the solution plus OH and H plus ions, because this is H2O, these are the ions. So between K and H plus, we always know that H plus is gonna win between these two. Between OH and Br, of course Br is gonna win because it's a concentrated solution. If it's a dilute solution, it would be otherwise. So Cl would usually win if it was a concentrated solution over O2. But since it's a dilute solution, O2 is gonna be found at the anode. Na, it's weaker than H plus, so H2 is gonna be found at the anode. Cu is stronger than H plus, obviously. So we're gonna find Cu at the cathode, and SO4 is weaker than OH minus. So you're gonna find O2 at the anode. And the last question for today, it's identify the element produced at the negative electrode. This is your negative electrode. And you can find, since it's CaF2, Ca is the cation, so you find it at the cathode. Ca and F2 is your anion, so you find it at the anode. Now, to write the half reactions, you start off with your ion at the negative electrode, aka the cathode. It's a red fat cat, so it's gonna undergo reduction. And since it's reduction, electrons are in the reactants. So Ca2 plus 2 electrons gives you Ca. And when you're writing for any halogen, it's 2, or well, any diatomic substance, you're gonna start off with 2. The thing and its charge gives off, if it's oxidizing or at the anode, 2 electrons plus the gas itself. Now in the exam, for the periodic, they gave us for N, nitrogen. So N2, you have to write its a half equation. How do you do that? You start off with 2N 3 minus, because it's obviously 3 minus N, gives off N2 gas and 6 electrons. You had to write 6 electrons because you multiply the 3 with the 2. You had to balance them. So that was a mistake a lot of students got. They wrote 3 electrons, or they forgot that N was negative 3 charge and whatever. So yeah, but that's it for today's exam. If they bring this in the exam tomorrow, this is the half reaction for nitrogen. Hope you understood everything. Have a good day.